So today we'll be talking about the section B of the St. Benedict's paper. Let us get into it. So question 6. In the diagram below, LM is a tangent to the circle with the center P at L, right? So the coordinate of P is -1 and -1. The coordinate of L is -4 and 3. We also have M, which is 0 and 6, is a point on the y-axis. Now, the first sub-question says determine the inclination alpha of line PM. To get your angle of inclination, the formula we use is this. M is equals to tan alpha. So we are trying to find this alpha. So basically, alpha is more or less by saying tan to the power of -1m. So the second function of tan m. To calculate our angle of inclination, the gradient is very important. Now, since we are working with the line of MP, we need to get the gradient of MP. The coordinate of M is 0 and 6. The coordinate of P is -1 and -1. So calculating your gradient, you're going to get. So the gradient is 7. Now to get your angle, I just need to put this in and put in 7. And this is going to give me, let's take out our calculator. So that's 81,87 degrees, okay? 81,87 degrees, and that will be your answer for the angle of inclination of alpha. So moving on to B. B says calculate the area of triangle PLM, okay? So now let's go to this. PLM is this. So we can extend this line, right? Let's connect P and L, right? So it actually looks like a triangle. There we go. Now, one thing we actually notice about PL is that PL is a radius. And from the question, we know that LM is a tangent. Now, if it is a tangent, we know that radius is perpendicular to tangent, making this 90 degrees, right? So if this is 90 degrees, it will help us get our question a little bit easier. Now, the area of a triangle is half base times height. Okay, and more specifically, is half base times perpendicular height. Now, if we take ML as our base, it will mean that this is my perpendicular height. So all we just need to do to answer this question, right, is to figure out what the distance of ML is using distance formula, figure out what the distance or the length of PL is also using distance formula, then put it into the area of a triangle formula, and you should have your answer. So let's do that real quick. Okay, so we have the base as 5. Now we need to get the perpendicular height. Also distance formula. So the perpendicular height is also 5. So writing this is our answer. So the area of triangle PLM would be half times 5 times 5. Okay, 5 times 5 is 25. So the total will be 25 over 2 units squared, right? We can leave it like this, or we could write it as 12,5 units squared, and that will be your answer. Let's move on to C. Now, C says prove that the equation of the circle can be given by this, okay? So let's go back to our circle. This is our circle over here. The center of our circle is -1 and -1. And the radius of our circle, because we actually got the distance of PL, the radius of our circle is actually 5, right? So using the equation of a circle when the center is not at the origin, the formula is written like this. Now all we just need to do is substitute our values for A and B and R, right? So since your R is your radius is 5, your A and B is -1 and -1, okay? So putting all this in, this is what you'll get. Now, looking at this, it doesn't look like the equation of the circle we're given here. So what we can do is that we can expand, right? So expand each of those brackets. This here will give you this will give you, okay? We also notice that the number is on the left-hand side, so we move it over to the left-hand side. And we're writing this, you can see that we have x squared plus y squared plus 2x plus 2y. 1 plus 1 is 2. 25 goes over, it becomes -25. 2 minus 25 is -23, which is exactly what we wanted. And that's it. So now let's look at D. Now we're going to do D1 and D2 together, right? We're going to do them simultaneously. Now D1 says determine the equation of the vertical tangents of a circle. And 2 now says write down the coordinates of the point of contact of the vertical tangents with the circle. Okay, so let's go back to our circle. Now they want vertical tangents to our circle. Okay, so a vertical tangent will more or less look like this. Okay, we could also draw another one on this side, also a vertical line. Now, if we draw a line from the radius to the point of contact of our tangent, right, and also that case there, we could also draw it that way. We understand that this is 90 degrees, right, because of radius perpendicular to tangent. Okay, now because it is 90 degrees, we know that this whole line is going to be like a diameter, which means that this is parallel to that one over there. Now, if they are parallel, it would also mean that our y value is going to be the same, right? So if this is -1 and -1, it means that this would be -1 for the y coordinate. And this one also would be -1 for the y coordinate because it's going to be a straight line through the line y is equals to -1. Okay, now our radius is 5, like we see over here. So meaning that we have 5 units to the left. If we are moving this 5 units to the left, it will mean that this here is actually going to be -1 minus 5, which is -6. And if this is 5 units to the right, it will be -1 plus 5, which is +4. So now your coordinates are -6 and -1, 4 and -1. Okay. Now, because our lines are vertical lines, and vertical lines, the equations of vertical lines are x is equals to, right? Because it is a line passing through your x-axis. Our answer for this is just going to be x is equals to 4, and this one here will just be x is equals to -6. And those are your answers, right? So coming back here, we could say our answers for the equation of the vertical tangent is x is equals to 6, sorry, x is equals to -6, and x is equals to 4. And for the point of contact, like we said, this here will be -6 and -1, and this would also be 4 and -1. Those are the answers that they wanted for this question. Okay, so let's talk about E. Now, E says another circle with an equation x minus 3 squared plus y plus 1 squared is equals to 18 is given. Show all calculations to prove that the two circles will intersect each other. Okay, so if these two circles are going to intersect, this is what we're looking at, right? So we're going to draw like 2 small circles, and the different scenarios you can get. These are the 3 scenarios that we could have between 2 circles to know if they intersect or they don't. Okay, so these are the 3 possible scenarios. The first scenario here, you would have 2 centers, and this is the radius of this center, let's call it R1, and the radius of this center, let's call it R2. Now we will say that if R1 plus R2 is equals to the distance of, let's call this A, let's call this B, is equals to the distance of AB. Okay, this is the scenario over there. The same thing would apply for this here. This here is R1, this is R2. Now, since this is A and this is B, if we try to get the full distance, right? So basically you're looking at it from that distance down to that one over there. In this case here, R1 plus R2 would be less than the distance of AB. Now for the third scenario, we're looking at your center of the circle here. Now this here is your R1. Then from here, center of my circle, down to there, that's my R2. Okay? Now we would say here that when you have your R1 plus your R2, now there's A, there's B, we'll say that it is greater, it has to be greater than the distance of AB. Okay? To answer this question, we need to get 2 things. We need to get the addition of the 2 radiuses. You get the radius of circle 1, the radius of circle 2. The second thing we need to get is the distance between the centers of those 2 circles. R1 and R2 to be greater than the distance we can say that they intersect. So that's what we're looking for. Okay, so let's clean this off real quick. Okay, so for this circle here, we understand that the centers are 3 and -1, and the radius here would be the square root of 18, which is 3 root 2. Okay, so we have the radius to be that. Now, for the other circle that we have, the centers are -1, right? Are -1 and -1, and the radius for this is actually 5. Okay, now since they both have the same y value, we understand that it's going to be a horizontal line. So we could say that the distance of our 2 circles would be 4 units. Okay, now we also need to get the addition of the radiuses, so we can say the radiuses, so we can say the sum of the radius. Yeah, the sum of the radius would be 3 root 2 plus 5, and that will give you, okay, so that's like 9.24. Okay, this is more or less 9.24. Okay, so as you can see, our sum of radius is greater than the distance of the centers. So for that reason, we definitely know it intersects. That's it. Next question, question 7. This question says the speed of 55 cars passes through a certain section of a road in Johannesburg and are monitored for 1 hour the day after the alcohol ban was lifted in August. The speed limit on this section of the road is 60 kilometers per hour. A histogram is drawn to represent the data. Okay, so this is your histogram, right? We can see that for each block, this here is 20 to 30, that's the speed limit or the speed range. From 20 to 30, you just have 1 car, right? 30 to 40, you have 7 cars. 40 to 50, you have 13 cars, and so on and so forth, until you get to 90 to 100, which there is only one car driving at that speed. Now, the first question says identify the modal class of this data. If you're identifying a modal class of the data, you're looking at the one with the highest frequency. And from here, the one with the highest frequency is the one with the highest bar, from 50 to 60, which is 17, right? So our answer for this is just going to be from 50 to 60, right? That would be your modal class. Then B says use the histogram to complete the table below. Okay, so we need to input the data that we have for our frequency and substitute into our table over here, right? So our 20 is 1, 20 to 30 is 1, 30 to 40 is 7, like that. So it's 1, 7, 13, 17. 1, 7, 13, 17. We have 9, 5, 2, 1. Okay, so this is 9, 5, 2, 1. Yeah, so the next we need to calculate our cumulative frequency. And to do that, we're just going to be adding the total with the next class, right? So it's like 1, add it to this, which is 8, add it to this, which is 21, 38, 47, 52, 54, and 55. Now our last cumulative frequency has to be the total of, if you add all those frequency, it needs to give you 55 and here. Now we know it's 55 because in the question it said the speeds of 55 cars. So obviously that's what we're going to take. Okay. Now the next question wants us to draw an ogive, right? A cumulative frequency graph for the above data. Now, drawing your ogive, we need to concentrate on these values, the upper limit of our class, and our cumulative frequency. We also need to include the first class. That's the only one we take the lower limit, and it must be like this, right? Okay, so let's plug this in. Let's construct our graph. Okay, so let's zoom out a bit so it makes a little bit more sense. Okay. So this side is your cumulative frequency, right? And on this side here, this is our speeds. Okay. So as we said, we're going to take each and every one, the upper ends of our class with our cumulative frequency, meaning 30 and 1, 40 and 8. Okay. All the points has been plotted in our graph. It all comes from this table. As I said, each of your upper limits with your cumulative frequency. All we just need to do is connect the points, right? And don't forget to always start from the first lower limit and start from the x-intercept, right? So it will be 20 and 0. Okay, so let's just connect this point. Okay, I'm going to reduce it a little bit so I can get everything. There we go. So this is exactly how our cumulative frequency graph is going to look like, right? Our ogive graph. And that's it. Now for C, it says the traffic department sends speeding fines to all motorists whose speed exceeds 66 kilometers per hour. Estimate the number of motorists who receives a speeding fine. Since we're looking for speeds above 66 kilometers per hour, we need to look at, okay, so 66 will be here, and we need to plot it to where it intersects with our graph, right? So we draw a line. So let's draw a line. So now we need to also look at what the corresponding cumulative frequency from 66 kilometers is going to be. So 66 kilometers per hour is going to be. So we're just going to draw this, and it is more or less going to be here. So this here is 45. Now at 66 kilometers per hour, the cumulative frequency is 45. Now, because they're asking us for exceeding that amount, what we need to do is subtract the total amount of motorists from that 45. So to get our answer, since our total motorist was 55, we subtract 55 from 45. It will give us 10, right? So we're looking at 10 motorists would receive a speeding fine. So we can say that 10 motorists would receive a speeding fine. So that would be our answer. That's it. So let's move on. Question 8. Now, question 8 says solve for A and B where cos open bracket A plus B close the bracket is equals to negative root 2 over 2. Now, if A plus B is an element of 0 to 180, we also have cos A minus 2B is equals to 1 over 2 if A minus 2B is an element of 0 to 180. So to answer this question, a couple of things jumps out to me. Since we're trying to solve for A and B, I would probably use simultaneous equation to help me figure it out. Okay, but before I get to the point in which I'll get two equations that helps me get simultaneous equation, this is still a trig question, right? And with trig question, which is a trig equation question, we normally try to find what is in the bracket, right? We can find what A plus B is, and we could also find what A minus 2B is. Okay, so that's what we're going to first of all find. Then we can try to figure out simultaneous equation next. Okay, let's get into it. Now, first thing first, let's draw out our quadrants, okay? We understand that in our four quadrants for trig ratios, everything is positive in the first, sine is positive in the second, tan is positive in the third, and only cos is positive in the fourth. Now, because we have cos and the answer here is negative, and this is between the first and the second quadrant, because this is 0 to 180, we understand that cos A plus B would be in the second quadrant. Now for the A minus 2B, right, since it's also cos and that's positive and it's also in the first and the second quadrant, the sole focus of this will be in the first quadrant, so we can say that this should be in this quadrant over here. Okay, so now let's try finding A plus B. So what we can say is this. Now, if I'm trying to get A plus B, I can move the B over to the other side. So this is what I'm going to get. So since negative root 2 over 2, as we said, is in the second quadrant, and the equation for the second quadrant is 180 minus theta, this becomes our reference angle. So that's why we have 180 minus cos this. Now, if you put this in, you're going to get, so therefore we have A plus B is equals to 135. Okay. Now we do the same thing for cos A minus 2b, right? So we have this as cos A minus 2b. Now this here is equals to 1 over 2, right? So we understand that A minus 2b. So this here will be the reciprocal of cos, which is 1 over 2. We have A plus B is 1. We have A plus B is 135, and we have A minus 2b is 60. Whenever you're trying to find two unknowns and you have two equations, the best route to take is to do simultaneous equations, right? Now, since we have two equations, which is this and that, I could say that doing them simultaneously, you're going to get so our B here is 25 degrees. To get our A, we just need to substitute into any of the equations that we got. So we can say this is. Okay, so that's our answers. So as you can see, A is 110 degrees and B is 25 degrees. So question 9. So this question says Mr. Antonite, I'm not really sure how to pronounce his name, but that guy is on break duty and is monitoring social distances of students on a field below. He looks down at Mazizi and Cameron from the first floor corridor, who are on the ground looking up at him. The angle of elevation of Mazizi to Mr. that guy is 90 minus 2 theta. Now they tell us here that AM is K meters, GC is 8 meters, MGC is angle MGC is 150 degrees, and angle MCG is theta. Okay. So the first question here asks us to get the size of MAG in terms of theta. Now, before we do all this, right, the first thing I do recommend you do is try as much as possible to redraw this. Now, because this is 3D trig, I'll recommend you redraw this as a right angle triangle that it is. So what we do understand is that this is K, this is angle A, angle M, angle G, and that's the 90 degrees over there. And we are told here that this is 90 minus 2 theta. So the question is asking us to find what this is, this angle over here, angle A. Now, since this is a triangle and sum of angles in a triangle gives you 180, you understand that if this is 90 and this is 90 minus 2 theta, we could just say that angle MAG would be 2 theta. Okay, so we have that there as 2 theta. Okay, so reason, sum of angles in a triangle. The next question says, show that mg is equals to k sine 2 theta. Okay, so now we are trying to find this one over here. Now that we've actually found this angle here to be 2 theta, I could say that to find this, I can look at mg is opposite of A, and since it's a right angle triangle, we can use SOHCAHTOA, right? This is my opposite, that's my hypotenuse, so I could use sine. I could write this. I could say sine 2 theta is equals to mg over k. And therefore, we understand that mg will just be k sine 2 theta. And that's exactly what they wanted. That's it. So question C says, show that MC is equals to K cos theta. Okay, so first and foremost, in the previous question, right, the previous question, we got MG to be K sine 2 theta. Now, because we do have this, we understand we have an angle side pair, and we're actually trying to find this one over here, right? This is the unknown. Okay, so we would use sine rule, and sine rule would say that sine theta over k sine 2 theta is equals to, we have sine 150 over mc. Sine 150 over mc. Okay, to find mc, the first thing we do here is cross multiply. Let's cross multiply here. This will give you mc is equals to, now sine 150 can be reduced into sine 30, right? Because it's in the second quadrant. So since sine 150 gives you sine 30, which is equals to half, I understand that this here will be k times, that is double angle identity. So this can be rewritten as 2 sine theta cos theta. Okay, so this is 2 times sine theta cos theta. All this over sine theta. Yeah. So as you can see over here, sine theta can cancel sine theta out. This 2 here can cancel that 2 out. So all you're left with is this and that. And that's your answer, which is k cos theta, which is equals to mc. And as you can see, that's exactly what they wanted. And that's it. Now, D says, show that the area of triangle MGC can be written as 2k sine 2 theta. Normally, since it is not a right angle triangle, the formula for area can be calculated using area rule, right? And the formula kind of looks something like this. You can say the area is equals to half A, B, sine or capital C, something like this, right? Okay, so it always has to be an included angle, right? So I'm looking for an included angle to help me get my answer. I'm looking at this here. I could look at an included angle in terms of MG and GC because I have 150. I could also look at an included angle as GC and MC because I have theta. I could try to figure this out, but I think it would be more complicated. So the easiest way I think I could do is just look at MG and GC. So taking K sine 2 theta, taking this as 8, and taking this as 150, right? That's exactly what I'm just going to write. So I'm going to say half times 8 times k sine 2 theta, the sine of 150. Okay, so this here can be written as half times 8 k sine 2 theta, right? Because this whole thing here gives you half. Because remember, it gives you sine 30, which also gives you half. So half times half is 1 over 4. 1 over 4 times 8 is 2. So I just have 2k sine 2 theta, which is exactly what these guys wanted over there. And that's it. That's your area. Well done. So question 10. So question 10 says, in the diagram, a cyclic quadrilateral ABCD is given with center O. Prove the theorem that states the sum of the opposite angles of a cyclic quadrilateral is equals to 180. Now, this is your cyclic quadrilateral, right? A, B, C, D. So we're trying to prove that the opposite angles are supplementary. So we're trying to prove, let's say, required to prove that angle A plus angle C is equals to 180. And we're also trying to prove that angle B plus angle D is equals to 180. Now, for us to prove this, we first of all need to construct. Okay, so the construction we're going to make is we're going to connect this A with O and also this C with O. So after construction, we also need to label, right? So we're going to label this part here as 1, and the reflex angle you have there we're going to label that as 2. Okay, so what we're going to do next is using the second theorem of Euclidean geometry. We understand that angle at center is equals to twice angle at circumference. That's what we're going to play around with. So I could say that 2b is equals to O1. Now the reason for this is angle at center is twice the angle at the circumference. Okay, so we could also say this, that 2d is equals to O2 for the same reason. Angle at center is twice the angle at the circumference. Now we also know that O1 plus O2 is equals to 360. And the reason is angle around a point. Yeah, angles around a point usually add up to 360 is a revolution. Since O1 is 2b and O2 is 2d, I can rewrite this as 2b plus 2 angle d is equals to 360. So dividing everything by 2, this here is therefore b plus d will be equals to 180. Okay, but since we are also trying to prove that a plus c would also be equals to 180, we understand that every quadrilateral, the sum of angles is always 360. So if a plus d is equals to 180, it would also mean that a plus c would also be equals to 180. And the reason for that is the interior angles of a quadrilateral. Right? It always adds up to 360, and that's it. So this here is the proof of this question over here. Okay, moving on. So let's talk about B. So B says in triangle ABC, D is a point on AB such that AD ratio DB is equals to 5 ratio 4. Now P and E are points on AC such that DE is parallel to BC, DP is parallel to BE. BC is not a diameter of a circle. Angle BDE is equals to 120 degrees. EC distance is 12 units and BC is 27 units. Okay. So the first piece of information we need to work with is that AD to DB is 5 to 4. So this is 5, this is 4. But because this is not the actual value but the ratio of the side, we could accompany our number with a letter, right, or with a variable. So we can say this is 5k and this is 4k. And k is a value that we can multiply to 5 and 4 to give us the actual value that should have been there. Okay, so that is what this first piece of information tells us. Now, every other information is actually in here. The fact that DP is parallel to BE, the fact that DE is parallel to BC, that angle D here is 120, the length of EC is 12, and the length of this is 24. Okay, so we've actually put in every single information that we're given in the original question. Now, the sub-question now says determine with reasons the length of AE. Okay, so we want to try to get this AE over here. Okay, so now because that DE is parallel to BC, right? We can see here that DE is parallel to BC. Okay, and we are working under triangle ABC, right? So all this is the sole focus is in triangle ABC. We would understand that AD over DB is equals to AE over EC. And the reason I'm stating all this fact is because of proportionality theorem. Okay, so whenever you have a triangle and inside the triangle you have two parallel lines, okay, we normally say that the sides are in proportion to themselves. Now with this at the back of our mind, we can substitute. We understand that the ratio of AD to DB is 5/4. We know the value of EC is 12. We can figure out what AE is. So by cross multiplication, we understand that AE is equals to 12 times 5/4, which makes AE equals to 15 units. Okay, so that will be your answer for AE. Now for 2 says find the area of AEB and ECB. So we are looking at AEB, which is this here, and ECB, which is this part over here. Okay. Okay, that's cool. This here reminds me of proportionality theorem. Now, because these two triangles are in between two parallel lines, they would have the same perpendicular height. The area of triangle AEB and triangle ECB will just be equals to AE over EC. This here would be AE over EC. Don't forget, it actually kind of comes from this, right? Half times perpendicular height times AE over half times perpendicular height times EC. They will both have the same perpendicular height, so they kind of cancel out. They will both also have half. They cancel out, as you can see. You're just left with AE and EC. So in that so doing, we understand that AE from the previous question was 15, EC was 12. So the ratio is just 5/4. And this will be your answer. That's it. Moving on. Okay, so we have C. So C says hence. Hence usually signifies continue or use the values that you got in the previous question to try to answer this. Determine the length of DB if it is further given that triangle ADB is similar to triangle ABE. So because these two triangles are similar, we know that AD over AB is equals to DP over BE is equals to AP over AE. Now, we will choose the ratios that we have values for, and that will help us get our answers. Okay, so now since we are trying to get DP, I kind of know that I definitely have to use this. I need to use this ratio here, DP over BE. Now the other ratio I also need to use is, let's see, AD and AB, because I actually do have that, right? So I'm also going to use this one over here. There you go, right? So this one here is not really important. So we can kind of leave this out for now. Okay, so we'll just focus on these two over here. So starting with AD over AB, we understand that, okay, let's clean this up first of all. Okay, we understand that AD is 5K, so AB would be like 9K. So the ratio is 5/9. Okay, so we do have this part to be 5/9 is equals to DP is what we are trying to find, and BE. Do we have BE? No, we don't. Okay, so we do not have BE. So we are actually trying to figure out what this here is. Okay, so we need BE so that BE can also help us find DP. Now, we see that in the cyclic chord DBCE, that if this is 120, this angle here would be 60. And if that is 60, now focusing on ECB, we understand that we can get BE using cos rule, right? Because that's an included angle. Okay, so that's exactly how I'm going to get BE. So what I'm going to say is, so let's just put a pin here. BE squared is equals to 12, 27, 60. Okay, 12 squared plus 27 squared minus 2, 12, 27 cos of 60. Okay, so putting all this in the calculator, let's see what we'll get. So this is 12 squared plus 27 squared minus 2 open bracket 12 times 27 close the bracket times cos 60. As you can see, our answer is 549 is BE squared. Right, so to actually get BE, we know BE is the square root of 549. So square root answer, we'll get 23,43. So BE is 23,43. Okay, so we actually now have BE here. So this should be written as 23,43. Now to get our value for DP, cross multiplication, this will give you DP is equals to 5 times 23,43 over 9. So therefore DP is equals to, let's see, so we're multiplying this answer by 5 and dividing it by 9. So this here would give you 13,02. So DP will be 13,02 units. Okay, and this here will be your answer. So the final question, question 11. A. Complete the following theorem statement. If two triangles are equiangular, then their sides are in proportion. So that will be the answer for A. Moving on to B. B says AP is a tangent to the circle at P and CB is parallel to DP. We are given that CB is equals to DP. We have a straight line CSA and let D be X and C2 be Y. Now prove with reasons that triangle APC is similar to triangle APB. An easier way to get this is that we know that this angle here will be equal to that angle here in my triangle. This angle here is going to be equal to that angle there in my triangle. And finally, that is equal to that. But we need to give reasons why they are equal. So let's go with APC. We have APC. We start with A for A and APB. So APB is APB. They also has A. Okay, so the first one would be, okay, we're going to write it like this. In triangle APC and triangle APB. We'll prove the angles of APC underneath this and the angles of APB underneath it. Okay. So for the first one, we said angle A. They both have angle A. So this angle A is equal to this angle A. So the reason for that is we have a common angle. Okay. So the next one we're going to prove is C and P, right? So we have angle C here for APC and P here, that's P3. So we want to try to prove that C2 is equals to P3. Now C2 is equals to P3 because of tan chord, right? That's my tangent, that is my chord. So this angle is equals to that angle over there. Okay, so we're going to say this. We're going to say that C2 is equals to P3, and the reason for that is tan chord, right? We don't have to say it, but we could also say that this is also equals to y. Yeah, since C2 is y, so this one here, this value here is y. Now finally, because we've proven two angles in a triangle, which normally adds up to 180, we understand that the third angle would always be equal, right? So the last angle we have here is going to be P2 plus P3 is equals to angle B. Angle B is angle B2, yeah? B2 is equals to B2. And the reason for that is interior angles of a triangle equals to 180. Yeah. That's exactly why that is equal. Now, because we've proven all three angles are equal, we can now say that therefore we know that triangle APC is similar to triangle APB. And the major reason is angle, angle, angle. That's it. 2 here says AP squared is equals to AB times AC. Okay, so for us to get this, we first of all need to rewrite our similar triangles as ratios, right? So we can say this here is AP over AB, right? First two is equals to PC over BP, right? Last two. And the last one is AC over AP, right? First and last. Okay, so whenever you have a question that you have AP squared, it literally means that the numerator has to be AP and the denominator has to be AP so that they'll cross multiply to give you AP squared. And that tells me that it's actually going to be this 2 here. Because I see that that's AP and AP. When they multiply, they give you AP squared. So that's definitely what you want. So cross multiplication there will be AP squared is equals to AB times AC, which is exactly what this guy's wanted over here. The next one here says that prove that triangle APC is similar to triangle CDP. Okay, so we're also having APC. APC, the big one there, is similar to CDP, right? So CDP. Okay, that's cool. So the first one we're going to prove is the angle P. This whole angle P that we have here. This is equals to D. And now that is equal because of tan cut. So if this is X, that is kind of also X. Okay, so that's the first thing we're going to prove. So we're going to write this. First of all, we're going to say in triangle APC and triangle CDP, we understand that P2 plus P3 is equals to angle D, which is equals to X. And the reason for that is tan cut. Then we go with C and P, right? So the C here is Y, and the P here is P1, okay? Now those two are equal because of alternate angles, all right? This is a parallel line. These are two parallel lines, sorry. These are two parallel lines, and we'll say that since they're parallel, that's like your N in front, right? So those P1 is equals to Y over there, okay? So we have it is C2 and P1, okay? So we're going to say here that C2 is equals to P1, which is equals to Y. So the reason for that is alternate angles. We're looking at parallel lines of BC and DP. BC is parallel to DP. There you go. Since we've proven two angles are equal, the last one will just say angle A is equals to C1, and the reason is interior angles of a triangle adds up to 180. Okay, then we can just say that therefore triangle APC is similar to triangle CDP, and the reason is angle, angle, angle. That's it. Okay, now question 4. Question 4 says AP squared plus BC squared is equals to AC squared. So this kind of reminds me of AP squared in the previous question, which was this over here, right? So I could actually say that AP squared is equals to AB times AC. Is that right? There we go. Yeah. Now also in the previous question, we actually have this triangle is similar to that triangle. So we're writing them in ratios. It would mean that AP over CD is equals to PC over DP is equals to AC over PC. Now, we understand that we have AP squared from that other question. We can actually find what PC squared is because this and this, you can see that's in the numerator, that's in the denominator. If you cross multiply it, this is PC squared is equals to AC times DP. I don't have AP squared, which is AB times AC. I have PC squared, which is AC times DP. So I could add both of them because it is this plus this. I could say AP squared plus PC squared is equals to AB times AC plus AC times DP. Okay, so my answers are coming together a little bit, right? Because I have the left hand side sorted, I just need to worry about the right hand side. I need to make everything on the right hand side equals to AC squared. If you go back to the question, we're told that CP is equals to DP, right? I could actually rewrite this, yeah, since CB is equals to DP, that would change this to look like this. And we also notice we can bring out a common factor on the right hand side. I could say that AC is common on both sides, so this is AB plus CB. Now going back up, let's look at this. This is AB, this is CB. If you add both of them, it actually gives you the whole of AC. So instead of me writing this here, because this actually gives you AC, yeah, times AC is equals to AP squared. So I notice I made a mistake here, just a little mistake, something I can correct. This here is not P squared, it's PC squared, right? So this change this to PC squared. There you go, PC squared. So the final step, AP squared plus PC squared is equals to AC squared, which is exactly, as you can see, what they wanted up there. Yeah, and that's your answer. That's it. Okay, so we're done with the second section of paper 2. We'll be trying out other papers in the next couple of videos. If you do like this, please like and subscribe, and see you in the next one. Bye.